Gamma ray burst. For a few seconds, somewhere in the universe, a single explosion outshines everything. Every star, every galaxy, all of it combined. That's a gamma ray burst. In a handful of seconds, it can release more energy than our sun will produce in its entire 10 billion year lifetime. And it does it from a beam far narrower than you'd ever expect. Here's the part that should bother you. That energy doesn't spread out in all directions. It fires in two tight jets, like a cosmic shotgun, which means the real danger isn't whether one goes off, it's whether one is pointing at you. If a gamma ray burst fired within a few thousand light years of Earth and we were in the firing line, it could strip away our ozone layer in seconds. No ozone, no shield from the sun's radiation. Some scientists think one may have already triggered a mass extinction hundreds of millions of years ago. And the worst part? We'd never see it coming. The gamma rays arrive at the speed of light at the exact same moment as the light that would have warned us. A rogue black hole. Most people picture black holes as fixed points, sitting quietly at the center of galaxies, minding their own business. A lot of them don't stay put. When stars die or galaxies collide, black holes can get flung out, kicked loose, and sent drifting through space on their own. We call them rogue black holes, and they are exactly as friendly as they sound. Here's the genuinely unsettling part. A black hole gives off no light, none. So one could be wandering through our galaxy right now and we wouldn't see it. We'd only know it was here by watching the things around it suddenly start to bend, stretch, and vanish. If one passed anywhere near our solar system, it wouldn't even need to hit us. Its gravity alone could fling planets out of their orbits and send Earth spiraling into the dark, away from the sun, to freeze. Astronomers have actually confirmed one of these drifting through the galaxy. The thought that there could be many more, invisible, silent, and moving, is not a comforting one. False vacuum decay. This might be the most terrifying idea in all of physics, and it starts with a simple question. What if the universe isn't actually stable? What if it just looks that way? The theory goes like this. Empty space might not be sitting at its lowest possible energy. It might be in a false vacuum, balanced, but not truly settled, like a ball resting in a dip near the top of a hill instead of at the bottom. Here's the problem. If that's true, then somewhere, at any moment, space could randomly drop to its real lowest state. And when it does, it creates a bubble of true vacuum that expands outward at the speed of light, rewriting the laws of physics inside it as it grows. Everything that bubble touches is unmade. Atoms can't hold together the way they did. Matter as we know it simply stops being possible. And because it travels at light speed, you'd get zero warning, no flash, no sign, no time. One instant you're here, the next, the rules that let you exist don't apply anymore. The Big Rip. The universe is expanding. You probably knew that. What you might not know is that the expansion is speeding up, and one possible ending to all of this is genuinely violent. It's called the Big Rip. The force driving the expansion is dark energy, and we barely understand it. But if dark energy keeps getting stronger over time, the expansion doesn't just continue. It runs away. Here's how it plays out, and it's grim. First, galaxies get torn away from each other. Then individual galaxies are ripped to pieces. Then solar systems. Then planets. The expansion gets so aggressive that it overpowers gravity itself. And it doesn't stop there. In the final moments, the expansion becomes strong enough to tear apart atoms. The very thing holding matter together loses. The really haunting detail is the timeline. The last second wouldn't be gradual. Everything holds together right up until the end, and then in a single instant, every structure in existence, down to the atom, gets pulled apart at once. Spaghetifffication. Let's say you fell into a black hole. Bad day. But the way it would actually kill you is somehow worse than just being crushed. The real term scientists use is spaghetification. It's genuine physics vocabulary, and it describes exactly what it sounds like. You get stretched out into a long, thin strand, like a piece of spaghetti. Here's why it happens. Gravity gets stronger the closer you are to the black hole. So if you fell in feet first, your feet would be pulled with vastly more force than your head. That difference stretches you. And the closer you get, the more extreme that difference becomes. Your body lengthens, then it narrows, then it comes apart, cell by cell, atom by atom, drawn into a thread, heading for the center. The detail that really gets people is this. For a big enough black hole, you could cross the point of no return without feeling a thing, fully alive, fully aware, calmly falling toward a death you cannot stop and cannot escape. The Great Attractor. Right now, our entire galaxy is being pulled towards something. We can't see it clearly. We're not entirely sure what it is. And we're moving toward it at around 2 million kilometers per hour. They call it the Great Attractor. It's a gravitational anomaly sitting hundreds of millions of light years away. And our galaxy, along with thousands of others, is being dragged in its direction. Here's the frustrating part. We can't get a clean look at it. It sits behind the dense, bright core of our own Milky Way, in a region astronomers literally call the zone of avoidance, because all that gas and dust blocks the view. So we're being pulled hard toward a thing we cannot properly see. We only know it's there because of the way everything around us is leaning toward it. Whatever it is, it's enormous. And the honest, slightly disturbing truth is that we're still arguing about what's even strong enough to be reeling in this much of the universe. Eta Carinae. About 7,500 light-years away sits a star that is actively trying to destroy itself, and one day it's going to succeed spectacularly. Eta Carinae is a monster. It's somewhere around 100 times the mass of our Sun, which makes it one of the most massive and unstable stars we know of. Stars that big do not live calm lives, and they do not die quietly. Here's a taste of what it's already capable of. In the 1840s, it had an eruption so violent it briefly became one of the brightest stars in the sky, throwing off more material than most stars contain in total. And it survived that. It's still up there. When it finally goes, it won't be an ordinary supernova. It could be a hypernova, one of the most powerful explosions in the universe, and there's a real chance it fires off a gamma-ray burst when it does. The good news is it probably isn't aimed at us. Probably, with a star like Eta Carinae, probably is the best reassurance you're going to get. Kilonova. Where does gold actually come from? Not from the ground originally. The gold in your jewelry, in your phone, was forged in one of the most extreme events in the universe. It's called a kilonova, and it happens when two neutron stars, the dense, collapsed cores of dead stars, spiral into each other and collide. Neutron stars are already absurd. A teaspoon of one would weigh billions of tons. Now, smash two of them together. Here's what that collision does. The impact is so violent it creates the conditions to forge heavy elements, gold, platinum, uranium, and flings them out across space. Almost all the gold in existence was born this way. In 2017, we detected one for the first time, picking up both the ripples in space-time and the light from the crash. Confirmation that this is real, and that it's where our most precious metals came from. So the next time someone shows off a gold ring, remember what made it. Two dead stars, violently colliding hundreds of millions of years before Earth even existed. Solar superstorms. Our sun keeps us alive. It's also capable of knocking out modern civilization in a matter of hours, and it has come close before. Every so often, the sun launches a massive burst of charged particles into space. A coronal mass ejection. If one of those slams into Earth at full strength, it doesn't hit our bodies, it hits our electronics. Here's the scenario that keeps engineers up at night. Back in 1859, a solar storm called the Carrington event struck Earth. Telegraph wires sparked. Some operators got shocked. Auroras lit up the sky near the equator. Back then, that was the whole extent of the damage. Now picture the exact same storm hitting today. Power grids overloading, satellites frying, GPS, internet, banking, all of it exposed. A truly large storm could take grids down for months. And in 2012, one of those monsters erupted from the sun and crossed Earth's orbit. We missed it by about a week. That's it. 1 week of timing between normal life and a global blackout. Rogue planets. When you picture a planet, you picture it orbiting a star, warm, lit, anchored. Now delete the star. That's a rogue planet, and there might be billions of them. These are worlds that got kicked out of their solar systems, flung into deep space with no sun to orbit. They drift alone through the galaxy in total darkness, no day, no warmth, no light at all. Here's what makes them eerie. They're almost impossible to detect. No star lighting them up, no glow bouncing off them. They're cold, dark planets moving silently through the void, and we only catch them in rare, lucky moments. Some estimates suggest there could be more rogue planets in our galaxy than there are stars. Sit with that. Trillions of worlds, wandering, unseen, in the gaps between the points of light we can actually find. And here's the quiet thought to leave with. One of them could drift through our solar system one day, frozen, lightless, and completely indifferent to whatever it disturbs on the way through. Tidal disruption events. At the center of almost every large galaxy sits a supermassive black hole, millions or billions of times the mass of our Sun. Stars orbit them. Usually that's fine. Sometimes a star drifts too close. When that happens, you get a tidal disruption event, and it's exactly as brutal as black hole physics suggests. The black hole's gravity grabs the star and tears it apart. Here's the gruesome detail. The star doesn't just vanish, it gets stretched and shredded into a long stream of gas, half of which spirals down into the black hole, while the rest gets flung back out into space. As that stellar material falls in, it heats up and blazes, releasing a flare of light bright enough for us to detect from clear across the universe. So somewhere out there, right now, a star that existed for billions of years is being unwound into a ribbon and swallowed. And the only trace left behind is a flash of light we'll spot long after the star itself is gone. Magnetars and starquakes. There's a type of dead star out there so extreme it makes the rest of this list look gentle. It's called a magnetar, and it has the strongest magnetic field in the known universe. To give you a sense of scale, a magnetar's magnetic field is trillions of times stronger than Earth's. If one sat at the distance of the moon, it would wipe the data off every credit card on the planet and scramble the atoms in your body. Here's where it gets worse. A magnetar has a solid crust, and that crust is under unbelievable strain. Sometimes it cracks. We call it a starquake, and when it happens, the magnetar unleashes a burst of energy in a fraction of a second. In 2004, one of these bursts reached Earth from 50,000 light-years away. From that absurd distance, it still partially disrupted our atmosphere and outshone every other source of gamma rays in the sky. 50,000 light-years away, and it still touched us. Let that one sink in. The Boötis Void. Space is full of stuff. Galaxies, clusters, threads of matter stretching across the universe, except for one region where there's almost nothing at all. It's called the Boötis Void, and it is staggeringly empty. A roughly spherical region around 330 million light-years across, holding a tiny fraction of the galaxies it should. Here's the comparison that makes it land. In a patch of space that size, you'd expect to find thousands of galaxies. The Boötis Void has only a few dozen. It's so barren that astronomers nicknamed it the Great Nothing. Now here's the genuinely unsettling thought. Imagine a civilization living on a planet in the middle of that void. For most of their history, they'd look up and see almost nothing. They could easily conclude their galaxy was the entire universe. We got lucky. We live somewhere crowded enough to see what's out there. A species in the heart of the Boötis Void might never have known anything else existed at all. Betelgeuse going supernova. There's a star in the constellation Orion you can see with your own eyes, and it's living on borrowed time. It's called Betelgeuse, and one day it is going to explode. Betelgeuse is a red supergiant, an aging star so vast that if you dropped it where our Sun is, it would swallow Mercury, Venus, Earth, and Mars whole. Stars this size are burning through the last of their fuel, and Betelgeuse is deep into its final act. Here's what grabbed everyone's attention. In late 2019, Betelgeuse suddenly started dimming, dramatically, and for a while people wondered if this was it. It turned out to be a giant cloud of dust the star had coughed up, a false alarm. This time, when it does finally go, it'll detonate as a supernova so bright it'll be visible in broad daylight, possibly for weeks. The strange comfort is the distance. At around 600 light-years away, it's far enough that the blast won't hurt us. We just get the best fireworks show in human history. The heat death of the universe. Every disturbing thing on this list is loud, violent, sudden. The way the universe actually ends, according to most physicists, is the complete opposite. It just slowly stops. It's called the heat death, and it's less of an event than a fade. Over unimaginable stretches of time, the stars burn through their fuel and go dark. No new ones form. The galaxies grow cold and silent. Here's the relentless logic behind it. Everything in the universe trends toward disorder, energy spreading out evenly until none of it is usable anymore. Eventually, even black holes, the last thing standing, evaporate away to nothing. What's left is a cold, dark, empty universe where nothing happens and nothing ever can again. No light, no heat, no motion, just particles drifting apart forever in a space too vast for anything to ever interact again. That's the real ending. Not a bang, not a rip, not an explosion, just an endless, silent dark where the universe finally runs out of the one thing it needed to do anything at all: energy.